Okay, this is my second attempt because our first video was too long. It was 8 minutes long. So I will try to talk a little bit faster and not explain every single part of our project. I will share the screen because I think it's easier. So we got this case, which is a production schedule at Falcon Die Casting, which talks about the company, Falcon Die Casting Company. This case talks about a problem that they have to satisfy for the demand. We have 12 weeks. We have three tables. The first table is for the demand of every week and for each part. The company has 5 machines. Each machine can only produce a specific part or parts. Table 2, we have the production rates for each machine. And we can see that machine 1 can only work in part 1 and part 4. Machine 2, 4, 3, 4, 5. And we have a yield percentage of each part and for the machines. And for example, we have a 60% yield for part 1 for the machines, where because the machines cannot work completely efficiently, it cannot work 100% efficiently, so they will be a waste. But this waste can be melted and reduced. It is on the case. And table 3 is for the setup times, hours for each machine and for each part. So me and my team decided to use our knowledge of GAMS, and by creating a model, we create a program in a code in GAMS, and it throw. Well, this is the description of the case, as I say, table 1, table 2, our variables, our model, our objective, which is minimize the overtime hours of the machines to in order to satisfy the demand. And we have so, like the assumptions, which are like pieces of information that we need to have in consideration for our model to work. And for part 1, we got these results of all of the 12 weeks, where we can see like the amount of hours of the machines, of the overtime hours of the machines for all of the 5 parts of all of the weeks. And for our team, we got the specifically on week 11, we didn't get any result of no solution returned, which means that it is unfeasible. So for part 1, we have that the production will not be satisfied because of the constraints and not enough overtime hours of the machines for enabling to satisfy the demand. Now for part 2, we had to create a new model in order to make the machines have the minimum hours of overtime for enabling the production and satisfy the demand. And for part B, sorry, for part for part B, we got these results. These are the minimum hours of all of the machines for the 12 weeks for each part. For example, in week 1, for the part 1, it worked at 49 overtime hours, which is the minimum. And part B talks a lot about the inventory that we need to have a specific inventory, a minimum, in order to complete the demand and satisfy it. And we got these results. And we got these results of the parts of inventory. Here it shows only since week 2. For example, this is the parts that should be in the inventory in week 2. This is for week 2, 3, 4, 5, 6, 7, blah, 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 into 12. So in conclusion of the case, we have that our second model is better for the company, because on the first model it only shows the amount of overtime hours, but they were not enough to satisfy the demand. And for part B, it, and with that model, with the inventory add, it can complete the demand and satisfy it. And that's what that is our this was our case.